Hi, nice to meet you all. So yeah, my name is Olman. I'm actually from Costa Rica, but I'm working in Germany in the German Aerospace Center. I work in the Institute of Communication and Navigation in the group of optical satellite links. So what we do is small satellites to test optical communication. So that's communicating with laser. I have zero knowledge on optics and lasers. What I do is the software for the satellites and for the terminals. So I'm basically like the only software guy there. What I do is like implementing telecommands, telemetry, data handling, that sort of stuff. And when I start working at DLR and start learning about flight software, I noticed that how they handle parameters were really like not nice, very cumbersome. So I start thinking, how can I improve these systems? And I noticed some space to innovate and improve the system. So that's what I want to present today. So yeah, I will start with a brief introduction of what's the parameter management system. Um, this is a component that is common in some flight software and also some flight software frameworks. It's basically just a key value storage service. So it basically maps a key to a value. The key can be a numerical ID most of the time. It can also be a string. And typically it supports like all the primitive data types like integers, floating types, Boolean strings. Um, and this component, this software component, I think is critical. It's very important in flight software because it basically gives us the ability to interface with the spacecraft or with the subsystem, with the device. It allows us to change the behavior by changing the parameters, but it could also give us the ability to see the state, to check, to monitor the state of inside the spacecraft. And it uh, parameter management system should at least support the set and get methods. So basically to write one parameter, the value of one parameter, or to retrieve the value of one parameter. Some examples of those systems, I just considering open source, of course. Um, F prime has the parameter management component. The outpost from DLR also has a parameter management class. And I'm not CFS expert, so I'm not sure if CFS has some parameter management system, but the most similar thing I found is the table service, which basically you can upload a binary table and you can change the configurations on CFS. Also, in, the POST standard from European Cooperation for Space Standardization provides a definition for a parameter management system, the ST20. And so what are the some limitations I found, not of specifically of the examples I mentioned, but the ones my group were using before. Um, and those are the followings. For me, the biggest limitation is that they are not user-friendly at all. So they were just used by the software people, by the embedded developers, but when someone, I don't know, from systems engineer or from optical guys or mechanical guys want to test something, then it becomes really hard for them, uh, mainly because of the following reasons. They use numerical values to identify the parameters, and we have hundreds of them. So we have to look into a list of numbers and sometimes memorize them, then it becomes pretty hard to use them. Also, they are always binary formatted. So if you want to set a get a value, you have to use the correct tools. Otherwise, it will be pretty hard, pretty daunting. Um, Sometimes they also have coarse access. With this, I mean that you have to send a whole data structure or a whole table, a whole binary file just to access or change one single parameter. And sometimes they just don't have the proper tooling for using them. Also related with this, the poor scalability. So you add hundreds of parameters, then it becomes hard to use, it becomes inefficient. And you know, like space systems are very complex for, even for a simple project, you can have hundreds of parameters. But most of the times you have thousands of parameters for a single system. And also lack of flexibility. Most of the times these systems, you froze them on compile time, and the only way to do a change is by updating the software. So you have to do an update on orbit in case you want to add more parameters, in case you want to change a parameter. I mean the definition of one parameter and so on. So yes, what are my proposals? What would I like to have in a new, in a more user-friendly parameter system? This is pretty similar to what I had just explained, but the other way around. So I want human-friendly names, so strings instead of numbers. I know you will think this is pretty inefficient, but I will tackle this point again soon. I also want to access the parameters one by one. I want to be able to access just a single parameter and not having to access a whole table or just downloading a whole file for accessing one parameter. I also want to use the parameter management system not only for configuration, but also for telemetry, because if we already have a nice way to interface with our system, why I need another system or another way to just access the telemetry. And last but not least, how are we tackling the complexity? And very simple, divide and conquer. And for this, I took inspiration from the space system model from the European Cooperation for Space Standardization. So the idea is basically to decompose the system hierarchically. So you have a system which is composed of subsystems, so on and so forth, until you go to the most basic unit of information, which are the parameters. So that's basically what I did. I built a tree structure composed of systems, subsystems, and parameters. So a tree. That's how I built my own parameter management system. So yeah, now I will briefly describe the API of this library that I built and that we are using. Yes, as I said, trees for parameters instead of tables or lists. So what the nodes of my trees are called system, just like that, and they just have one name, and they can have several subsystems. So I yes, as you see there, I just create like a top level system that has no parent, and then I can create subsystems that have other systems as parents. And then the parameters. The parameters should have one name and one system parent. And they have a specific type, of course. It can be any any primitive type like booleans, integers, unintegers, integers and unsigned integers, floating types. I can also do arrays of any of those, strings, and I'm also working on the blob. This is a base 64 and the date types. And this is basically how I build the hierarchy in the tree. You can see there, like in the right side, or it will like in a more graphical representation. And if you notice, it resembles somehow like a file system where you have directories, and inside the directories you have the files, which are basically the analogy to the parameters. Then in the code, how I can use the parameters, as I said, two very simple and basic methods, the get and the set. And that's how I access the value of each one of the parameters on the software. Okay, so if you don't like strings to access the parameters from like outside, you can still do it by numbers, because the trees, it's very easy to index the nodes of a tree. So you can still use unique numbers to access each one of the systems and each one of the parameters. So it becomes more efficient accessing the parameters. And you can also build a lookup table, a lookup array, and you will have constant access to any one of the parameters using the indexes. The only downside is that um, you cannot choose the indexes. So the indexes are assigned in runtime based on the position on the tree. So if you depend on if you are at a new system, the indexes can change. So you have to be aware of that. Um, Another cool feature of the library are the groups. You can think about like protobuf structures or um, yeah, basically a list of parameters for serialization and deserialization. And this is pretty useful for implementing interfaces, implementing like collecting telemetry, storing a list of parameters. Like I want just some parameters to be non-volatile and I want to store them in a file, or I want to take this list of parameters and store them in a log file, or I want this list of parameters to be the configuration, the arguments in a telecommand. With groups, I can do this very easily. Also, I can change those groups in runtime. So if at some point I notice like, okay, this parameter doesn't tell me anything in telemetry, it's just taking space there, I can remove it from the group. For example, groups are very handy for that. And other features, I have implement callbacks. So execute a function whenever I change a parameter. With callbacks, I can also do like range checking, alarms, whatever. Like I don't want a parameter to go out of this range, or just, yeah, let me know when this parameter it's getting to a certain value that it can be problematic. I can use callbacks for that. Also search functions for yes, to search in the tree based on strings or integers. Also functions to convert from to and from strings. And yes, using the groups, as I said, to serialization and deserialization, to binary, CSV, JSON, YAML, and it could be extended very easily. Um, so it started as a C++ implementation, but it has been growing in the recent couple of months. I have also done a Python implementation, so my colleagues that are not software, are not working in software, can just easily implement a script to test the devices. I have also implemented a transpiler that I will talk about briefly soon, and I'm working currently in a command line interface. So about the transpiler, I create a YAML scheme where I can define all the systems and parameters in a more like, so not in software, but it just in a YAML file and text file. It's the same. So I define the systems, the subsystems, and the parameters. That's how I build the tree in the YAML files. And then with this model, I can do several things. And the cool thing is that I can use this include keyword on YAML. It's not standard, but it's supported by Python library. And I can like separate all the parameters in several files. So instead of having a huge file, I can have several recursive files. And so I can give like the ADCS guys to just work on this file. That will be their system. And then I can include it in the OBC, so the OBC knows what are the groups and the parameters on the ADCS, for example. So then I take this model and I can generate the C++ code. I can also generate the documentation, and I can load it in the CLI. This is a work in progress, but I can load it in the CLI, which is Python implemented, and then use like a file system style navigation to search and set and get the parameters. And I also can plot these values using Python. So this is an example of a Python script. I load the YAML file with the model. It will create all the parameters in runtime. I will tell them how to access this device, which is remote. So in this case, I have implemented two getaways, UDP and CSP, the CubeSat Space Protocol. And just like that, I can set like, okay, just set the value or get the value of this parameter. Yes, for the CLI, as I said, I'm implementing this like file system style to navigate over the trees, which I find is pretty friendly, pretty intuitive. You can find a parameter pretty easily because you have to navigate and open one system and then open another system. You know, like if you want something from the ADCS, you just have to change to the ADCS system and then to whatever other system you want until you find your parameter and you can set or get the value. You could also do queries, so like just filter over all parameters with a certain name or a certain value. This is also a work in progress, but I think it will be a nice feature to have. And that's basically it. Some things I have in my roadmap in the near future, so it's access control. How to protect parameters depends who access and where they access it. Trace safety model, currently I have not considered threats. It's up to the user how to protect the trees and the parameters. That's also something I really interested to tackle in the next months. I have also thought about like a standardized tree on how to like let's think about like Linux. You know, in Linux how where your SSH key is, or where the libraries are, or where the binary executables are, or where the network configuration is. Maybe we can also do this with spacecrafts, and you create one application and the application knows how to access the spacecraft, how to get the information of the battery, the attitude. It could be a way to do it. And yes, I'm not C++ expert. I'm actually did this library because everyone in my institute is using C++. But I would really like to do this in Rust. Maybe in the next couple of months or years, I will start the Rust implementation. And that's it. Please let me know what do you think about this. If I would really appreciate any feedback to continue improving this. Thank you.
Thank you. Questions?
Great talk. One thing I was going to ask is this is described as parameter management. I'm not sure if you're using it on vehicles yet, but my question would be, is this limited to just being used for things one would describe as parameter data items, which change infrequently, or have you thought about using it for things more like real-time commands and telemetry?
Yes, they are used for real-time systems. So like embedded systems with low resources for control algorithms, but also for network configuration. I can use it for whatever in the software. Thank you.
So one of the limitations you mentioned at the beginning was that modifying or adding a new parameter required a software update. Does your current solution solve that problem? And if so, how?
Okay, yeah, thanks for the question. So yes, you can currently add parameters on runtime. I prefer, of course, to use static allocation. All the examples you saw are static allocated in stack. You can also create new parameters on runtime using like the new keyword on C++. When would I currently not using it for my projects? I mean, it's available if you want to use it. I'm not currently using it, but I think it could be useful if you are going to do some sort of scripting, for example, and then you want to create a new parameter that is not in the spacecraft. Yeah.
We can take one more question. I don't have anything online in person here.
Hey, thank you. Great presentation. Maybe to expand on the question that was asked earlier, I think they were focusing on the commanding side. So parameters might be reading telemetry items like what's the voltage of this thing, but on the commanding side, would you have a command of like take photo right? Is that kind of mappable into this parameter system, or?
I didn't get the question.
So
completely.
the primitives that are included in this parameter library are
Yeah.
parameters, like values that you can read or set. But can you invoke behavior from this as well as the command like take photo? You know, that's not necessarily a parameter like reading a voltage.
So I think like this, like how you utilize the parameters programmatically in your software. So you do the get and set. So for example, if I want to change the mode of operation of my satellite, I send the command to change the mode parameter, and then I do the get. And if mode is 1, I will do this. If mode is 2, I will do this. Like, I don't know if that the question goes on that sense.
Okay, so it's like modifying a state machine and then changing your behavior.
Yes.
That.
So like this library is just parameter management. So it's just data handling. But with those parameters, you change the behavior of your spacecraft.
Okay, thank you.
Okay, we have a question here.
I'm curious if you're doing any kind of data integrity checking or protection. Like if somebody writes a new value, are you maybe computing a CRC over the length of the data structure that you're retaining, just so that you can check when they read it if it's been corrupted by radiation or something?
Yeah, thanks for the question. No, that's not included in the library. I'm trusting on the middleware that I'm using for that. It could be either I'm using CSP mostly, CubeSat Space Protocol, but I don't know, you can use Ethernet, IP, TCP for relying on that check. Yeah.
We have one last question online. How does this differ from SQL?
From
SQL?
SQL, it's completely different. Yeah, this is for embedded systems. You access the parameters via like a string or a number. It's not like you do get from a table. So maybe this maybe I didn't use the correct name. I didn't mean SQL queries. I just mean like filtering over the tree and find yeah, parameters that match a certain value or a certain name.
Great. Thank you so much.
Thanks to you. And okay. I have just one commercial ad if I can. I would really like to do a PhD on some topic like this, like flight software, frameworks, or even things like that. So if anyone, I also have the how do you say the budget from DLR, the time to they will pay. I will basically just need a professor. So if anyone is interested or knows, please let me know.
You can post it on Slack channel and follow up with people for